Sunny Guha, and I will give a short 15-minute talk about my experience in Datathon and what I learned from it, and so on. 15 minutes is a short time to cram in anything useful, so I just compiled a bunch of random things, and hopefully you'll like it. So let me just open up the slides. Awesome. So getting off the ground in a data science competition is the title. Just a bit about me. I have a PhD in physics, and my specialization was string theory and quantum gravity. Now, that has nothing to do with data science, nothing to do with computer science or machine learning. But my team and we ended up winning in one of the categories in Datathon 2019. So I'm the perfect example of someone who had no background in this field or no prior knowledge or very little prior knowledge who still did well. So if I can do well, I believe any one of you can do well. So, and currently I work at MathWorks, and I recently started working with the deep learning performance team. So let's begin. Before I begin, the most important thing, whatever I say is just my opinion, and nothing that I say is new, because like all these things you can find online, or all these things like you probably already know, but all these things are just my opinions on how things are. And also, everything that I say is meant for a competition. A data science competition is not meant to be taken in a research environment. It's just meant for a timed machine learning or data science competition. So even though I don't have a background in computer science, I do have highly specialized mathematical skills because I have a PhD in physics. So I know ins and outs of algorithms, and I know how they work in great detail. But I never felt like that knowledge was useful to me, because a machine learning competition or these data science competitions are not about knowing ins and outs of algorithms, because you would never be implementing something from scratch. You won't be building your own architecture. It's about knowing when to apply or where to apply rather than knowing how to apply, or rather how it works. So I have an image over here, which you might have heard this news, this 15 or 16-year-old teenager who wins Kaggle competitions. So I'm sure like most of you, or like at least I know more math than him, but clearly he's winning competitions. So you don't have to be a computer science guy or a math or have statistics background to excel in these competitions. And that's one of the key factors. So if you ever see a Kaggle competition, the top performing models are exactly the same. It's about how much pre-processing, fine-tuning, and some bag of tricks that people do. So yeah, the key takeaway point is that you don't need to have a heavy background in machine learning or those kind of things to excel. So just with some intuition, some basic math, and some practice, you can do pretty well. So let me first begin with the do nots. Since this is a timed competition, it is very important that you manage your time and write as little code as possible. So, which is paradoxical, because we are in a coding competition. Like, why write little code? Because you don't want to waste time writing the same set of codes. For example, like the training loop. Training loop of like billions of models is more or less the same. So just like go online, find a training loop, copy paste into your code base, and just make the changes as necessary. Don't reinvent the wheel. That's most important, because you ideally you'd want to spend most of your time pre-processing or training or iterating over your models, because that's where you need most of your time. And of course, do not ever implement algorithms from scratch. It's a waste of time. It leads to poor performance. And in a deep learning setting, always use pre-trained models. Like never, ever, ever write your own models. This is something that I learned the hard way, that accuracy is not everything. It's hard to see right now, but like especially going into industry, I realized that an explainable model is more important than a black box that performs better than that explainable model, because you want to know your model has to be robust, and you have to know like why it outputs a certain thing and when does it do it and those kind of things. So accuracy is not always everything. And also, don't jump on a problem immediately. I know like when people get the data set, you just like want to quickly apply your algorithms and so on to it. But just take your time going through the data, understanding the problem structure well, and also like think about some various strategies that you want to use to attack the problem. I'm sure you guys know this, but I'll still reiterate it. Just make full use of cloud resources. So you have Google Cloud credits, I believe. You also have free Google Colab. You also get Kaggle. Well, you can always create Kaggle notebooks, and you get 9 GPU hours per day. So during my time, what I used to do, I used to have 2 Google accounts. I used to have like 2 Kaggle accounts. So I will simultaneously train 4 models or fine tune 4 models at a time. So just make good use of resources that are available to you, and rather make full use of resources available to you. Um, During my time, we did not have any GPU category, as in like we didn't need to use a GPU. But then like if you need to use GPU, you can use this small command to check what GPU is allotted to you using NVIDIA-SMI. It just tells you like what is there. If you get a crappy GPU, just close the collab, refresh it, and then just try it again, and you might just win the lottery and you get a better GPU. Some useful libraries, you guys know scikit for basic machine learning, pandas, numpy, TensorFlow. I like TensorFlow over PyTorch because TensorFlow is very quick for prototyping. If I just want to like import a model or just like write a small model of my own, I can do that in 4 or 5 lines in TensorFlow. So I like that about TensorFlow. Um, Utilities, Seaborn and Matplotlib rule in plotting and those kind of things. Some other less known utilities I want to talk about. XGBoost is a library that you would be using a lot. I will talk about that later. It's a gradient boosting library. SpaCy and NLTK are used for natural language processing. Now, they are very useful in places where suppose one of your feature is some text. So with spaCy and NLTK, with one command, you can like do all the text-based processing, use lowercase all your data, or like get rid of spaces and all that sort of things. Dabble is a very useful small utility which basically pre-processes the data for you. So all you need to do is just load the data. It takes in a pandas table, and you can just quickly with one command normalize and just get rid of all the nans or do all the processing with one command. It's just hassle-free. And also, like, since I work for MathWorks, I have to mention MATLAB. If you do have MATLAB installed in your system, just give it a shot because MATLAB already comes with machine learning tool. Well, you might have machine learning toolbox installed, and that has a lot of algorithms you can just like plug and play. So, and also the performance of MATLAB 2020 is up to par with XGBoost. So you might want to try it out. Okay, so here are the this is an important slide. Here are the tips and tricks that I learned during my time at Datathon, and also like later on talking to other people and so on. When in doubt, use XGBoost. So XGBoost, or the gradient boosted forest extreme version, is the most used algorithm in machine learning competitions. People use it for classification, people use it for regression. Just know one flaw, that it is prone to overfitting. So you need to take that into account. So here I have a list of some recent Kaggle competitions and their types, and you can see like what was the winning ML library: XGBoost, 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 XGBoost. This is another gradient boosted one. So yeah, so XGBoost wins a lot of times. So when in doubt, use XGBoost. Also, if you have a large number of features, just reduce the number of features because you want your model to be slightly more interpretable. I use autoencoder, but the drawback to using an autoencoder is that like it decreases the interpretability. So either use scikit's top K features or something. Again, like this depends on your use case. A new strategy that a lot of people are employing nowadays, and this is something that we did during our time as well, is like combine a lot of models. So if you combine some models, that just reduces the variance of your output. So it's always good to combine models, or like make an ensemble of ensembles or ensemble of models. So as you can see here, this group had 35 models stacked together. So yeah, that's useful. As data pre-processing is very important, spend a lot of time doing that. And also keep in mind, some algorithms react badly to normalization. So the data normalization step is not always useful. In my experience, XGB reacts badly to data normalization, so just keep that in mind. Also, a very important thing, iterate fast, iterate often. If you have multiple models, I would suggest that you train and test different models on a smaller section or a smaller fraction of your data set, and just figure out which model is performing better, and then just fixate on that model and fine tune that. So when you're fine tuning, I prefer to use just fix one parameter and then move the other parameters, or rather, sorry, fix every other parameter and move one parameter. And also, like always, like have 4 or 5 instances running on different clouds so that you better utilize your time. Also, scikit-learn has 2 functions that do hyperparameter tuning on its own, grid search and random search. But this small utility, tune sklearn, is way better, and it does a pretty great job. So I urge you to use this one. Here are the list of standard algorithms for the different tasks that you might encounter. Again, when in doubt, use XGB. So now let me quickly give you a brief overview of our project, which I did with Chen, Prajakta, and Srinivas. So the scenario was basically we had to predict equipment failure. So yes or no. And so it's a binary classification. And the data set was pretty skewed. So as you can see, it's pretty skewed. So there's a heavy class imbalance. Now, this is an anomaly detection kind of problem, and these are like very hard to deal with because of this imbalance. There are multiple ways, very different ways of like tolerating this imbalance. And the way that we decided to approach this problem was use XGBoost, use a Gaussian discriminant and a neural network. And then we stacked them together and did a majority voting. Now this stacking operation and then slight changes to the neural network resulted in excellent performance, and that's what led us to us winning. But the funny thing was that all the top performing teams used XGBoost as well. So that's the crazy part. Now, we fine-tune XGBoost a lot, and we spent a lot of time fine-tuning it. This Gaussian discriminant was pretty straightforward. In the neural network, instead of having binary cross-entropy loss, we added a focal loss function. So focal loss is basically binary cross-entropy loss, but modified by a gamma factor. What it does is it penalizes the minor class higher than the major class. So it's useful in settings which have class imbalances. So this loss function, stacking things together, and a lot of fine tuning led us to great performance. So the code is shared over here. So if you have time, have a look at it. And it was a fun project to do. I learned a lot in this. Just to like, since I'm reaching my endpoint, some useful resources. Coursera has a lot of useful resources. You can master machine learning, deep learning, reinforcement learning on your own. You never need to take a course. You don't need formal education. With Coursera courses and a lot of resources available online, you can learn things on your own. So it is easy and it is possible. So the Stanford machine learning course is excellent. You definitely need to start there, and you definitely need to like have a look at it. The deep learning AI courses are outstanding. The neural network, natural language processing, TensorFlow courses are all outstanding. Also, like some resources that I use on a daily basis is like I read Medium blogs. I also post Medium blogs. Archive Sanity is a great way to be updated with current research work because it curates top 30 papers, 30, 40 papers every week, and you can just skim through them and see what's the recent development, what's the recent research that's going on. Reddit Machine Learning is very active, and you will get to know all the great work, great papers coming out and everything. So definitely go subscribe to it. Couple of resources that I would like to mention is TensorFlow specialization by Google is useful, and I have seen that it is pretty useful in industry as well. And Workera.ai is by deeplearning.ai, and it's a good resource to find jobs in AI. So since it's a part of deeplearning.ai, it recommends you jobs pertaining to your skill set. So it's a good resource to keep in your resource list. And there are billions more resources because AI is a booming field. So by no means is this complete. It doesn't even capture like 0.001 fraction of what's out there. So I come to the end. The most important tip of a hackathon is to have fun. Don't stress out. Winning is not the point. The point is to learn, make collaboration, bounce around your ideas, enjoy the time. This is a very rare opportunity. I've met a lot of people, and very few have had the experience of a machine learning hackathon. Like very few people go to hackathons. Very few even like machine learning hackathons are just happening right now. Like it's happening. So yeah, have a great time. Have fun. You'll meet a lot of awesome folks. So again, a big thanks to the Datathon team for organizing this and organizing it during my time as well, and also like calling me to give this talk. So, and if you ever need to contact me, this is my email address. You can reach me on LinkedIn, and there are like multiple other ways you can reach me at. So yeah, have a great time.